I want to talk about the very simple Turing models for the supersymmetric invariant Lagrangians to describe the supersymmetric transformations to make the exchange between the fermion space and the gauge boson space. So there are some specific examples. For chiral supermultiplet, it means that there are no interactions, and the chiral supermultiplet means that there will be the one scalar piece and one fermion piece, and there will be some exchanges under the some transformation, and there will be some additional field out which could auxiliary fields, but there are no kinetic terms, so it will not considered in our discussion. So we can write the scalars per multiplus as the scalar part and the fermion part. So scalar part, there are no further interactions. So there are no interacting case, and all particles are mass loss. So I will write only the kinetic terms of the complex scalar fields, and also similar for that the fermion part. Inside of the Dirac four component spinner, I will write about two component spinners to describe the transformations between these scalar and spinner fields. And lattice defines of the supersymmetric transformations exchange between the scalar fields and the fermion fields as like that. First of all, we will introduce the Grassmann number, small infinitesimal parameters epsilon, and actually this epsilon has a mass dimension of the minus 1/2, and is because the such as some Grassmann number status and the spinner has mass dimension of the 1. So spinner has a mass dimension of the 3/2. So Grassmann number is the -1/2. So last defined the supersymmetric transformations of the scalar field that applies to the epsilon and the psi. So pi the transform as a pi prime, which is defined as a pi plus delta pi, and the delta pi is epsilon and epsilon size, and the mass dimension is a constant. And also for the complex conjugates for the pi star, it has such a transformation term. And in the contrast, we can define the supersymmetric transformations of the fermion, delta psi, and there will be the some derivative partial mu pi, which has the mass dimension of the power of the 2, and the 2 powers, and if we multiply the epsilon, then there's to the -1/2. So there are some mass dimension of the consistence, and to make the Lagrange invariance quantities for the Lagrangian, so there will be some Pauli matrix to multiply. And also for the complex conjugate of the spinors has such a transforms. And if we consider some of the transformations of the scalar part of the Lagrangians, then the scalar part of the Lagrangians actually the kinetic terms of the complex scalar field. So we'll consider that just the order of the epsilon 1, order of the epsilon 2 will take note he is as the infinitesimal small parameters. So for the complex conjugate of the scalar, such as transform, so delta L has such epsilon daggers and psi daggers term, and also for the transformation of the scalar field has epsilon daggers psi daggers, so epsilons and the psi, so we can write that such thing. So similarly, also we can calculate sort of the transformations of the fermion part of the Lagrangians. The fermion part of the Lagrangians is actually the kinetic terms of the spinor. So for the other joint spinor, there's other joint spinors is transformations that given like that epsilon partial means to pi star, and for transformation of the penis epsilon dagger partial means pi, and by the integration of the part, there are some total derivative terms, which is the used by the integration over the both space time standard 0, and the other terms are just the minus signs of the delta L scalars term. So just supersymmetry transformations of the scalar part and the fermion part of the Lagrangian will cancel the shared exactly. So total Lagrangians are invariant under such a supersymmetry transformation. Can be written like that. So option is invariant. Also, we can analyze some auxiliary field F, which has a mass dimension of 2. If we add such up stars and up, the other minus supersymmetry is still invariant. F will also transforms, but F does not have the kinetic term. So by the equation with the motion, so we can remove sort of such auxiliary field. That is virtual particulars of cell. And because there are some of the symmetry, Lagrangian invariance of the specific transformation, there are some net current will can be defined. So that is some of the definitions of the currents in the field theoretism. We can calculate sort of the supercurrent. And now there will be the two terms, epsilon times j mu and epsilon diagonal j times mu, and each supercurrent will be conserved. So the continuity equation is satisfied. And we can define the Shepherd charge as integration of the Shepherd currents over the spacious volume. And actually, such a Shepherd charge is the generator of the supersymmetric transformation, which is the supersymmetric transformation that can be written as the exponential IQ epsilon, where the epsilon is the infinitesimal parameters. Also, from the classical mechanics Hamiltonian's formalism, such a commutative relations of the generator and some specific physical quantity is actually the infinitesimal change of such a quantity with some specific parameters. For example, in the classicalism, Poisson broadcast of the Hamiltonian and the physical quantity hx is actually the delta x of the delta t, where t is the time, and there's also similar behaviors in the quantum mechanics. So we can write such a commutative relation and generator. So the specific quantity is that the infinitesimal change of the quantity under such transformations, which is generated by the such a z. So from that formalism, we can write the generator is actually the Shepherd charge, which is defined by the Shepherd current, epsilon q and epsilon Lagrange q dagger, and that acts as some specific quantity. Then from the using the Jacobi identity, commutators of the BC bus and the commutators of I and the BC totals. So and the permutation of the I and BC are actually equal to 0. We know that such as two supersymmetry transformation commutation of the delta 1 and delta 2, the proportional to the partial mu. So we can write the anti-commutative relation between the supercharge as p mu. So it's consistent with the extended supersymmetry algebra. So the point is each scalar and the fermion fields exchanges the other under the supersymmetry transformation, and we can construct sort of the Lagrangian invariant under the such a transformation, and we can define that of the supercurrent and supercharge, and actually supercharge is generators of the supersymmetric transformation, and that are very simple examples as a toy model of the supersymmetric invariant Lagrangians with the mass loss non-interacting and the new auxiliary field just exchanges of the fermion and scalar field.